Thank you. Thank you, everyone. I am an engineer whose inspiration comes from the chemistry of the natural world. I marvel at the chemistry of life, at the beauty and remarkable capability, the complexity of its products, the impressive ways that living systems can extract energy from the environment and build new life from simple, abundant, and renewable starting materials. I am also an engineer who is deeply concerned about what we are doing to our shared home, to our beautiful earth and all of its other inhabitants. Because I do not want to live in a world with 10 billion people and no chimpanzees, no rainforests, no coral reefs. And I feel that if we are to feed, clothe, house 10 billion people without destroying our beautiful natural environment, we may want to learn something from nature. Because nature's remarkable chemical transformations are catalyzed by enzymes, the protein machines that transform one form of matter into myriad others, and that do chemistry no human being can mimic or master. Now, equally awe-inspiring to me, however, is the process by which nature created these proteins, and in fact, everything else in the biological world. That process of evolution, which is a grand diversity generating machine that's responsible for the enormous diversity of life, starting from our universal common ancestor more than 3 billion years ago. It's the living world's recipe for adaptation, optimization, innovation. And it's just a simple algorithm of mutation and natural selection. 25 years ago, we struggled mightily to engineer nature's catalysts, the enzymes, to make better ones that would be suited for human purposes. And we did not, and still today, we don't know how the DNA sequence encodes this function well enough to reliably design a useful new enzyme. And therefore, I turned to nature's design process, evolution. Evolution by artificial selection in the test tube circumvents our profound ignorance of how DNA encodes a great enzyme and allows us to create new biological solutions to human problems. Now, today I'm focusing on sustainable chemistry done biologically. And here I just offer you one example, Provivi, which is a small company I founded with several students to produce insect pheromones to replace toxic pesticides used in the major row crops all over the world: corn, rice, soybeans. We disrupt mating of the most destructive crop pests simply by spraying some of the female moths' Chanel No. 5 in the field, which confuses the males. And no mating means no caterpillars and no crop damage. Non-toxic, doesn't kill other insects. Farmers in Mexico today, for example, are using this to replace insecticides, which damage humans and the environment, killing beneficial insects like the bees. And we're deploying these insect mating pheromones in many parts of the world this year: Kenya, Indonesia, Brazil, where we can mass produce them using biological production methods that were just developed recently. It's my great honor to be part of this academy, and I thank you for asking me to be part of it. I look forward to working with all of you to make sure we leave this world better than we found it. Thank you.